Okay, we are ready. Okay, welcome back. First of all, my apologies to everyone for the brief inconvenience. We had a problem with the schedule. It's all on our own. We did make a mistake, so we are sorry, and it's our fault, not unfortunately not the speaker fault. So we are deeply sorry for that. But moving on, we have our next talk. Here is Stevan. Stevan is a senior Android engineer in S-Mobile. And he will lead us to work on Jetpack Compose. You know, migrate your UI to Jetpack Compose because Jetpack Compose is awesome, I think. So I leave you the stage.
Grazie. Ciao a tutti, grazie per essere venuti al mio talk. So yeah, that's all from me in Italian, and I would like to thank to my colleague Pepe for helping me to translate this. Hopefully there are no any curse words in it. Otherwise, I'm sorry for all the Italians here. So I'll try to explain today how I dived into Jetpack Compose and what should you know before diving into it. So firstly, a few things about myself. So I'm a software engineer working in mobile technologies for already over 7 years. I worked across several companies, and I'm also trying to do a bit of entrepreneurship myself. So yeah, I founded my own company. It's called S-Mobile. And you're probably asking yourself why I'm in a t-shirt now, because yeah, it's specially designed for this event. Yeah, here is a QR code if you want to know more about it. So yeah, I guess we can start with the topic. So first things first, let's define what is Jetpack Compose. It's a declarative UI toolkit, and in its declarative approach, widgets do not expose any getters or setters, nor themselves are exposed as objects. So how you actually update your layout, you just have to pass the UI state to your composable function, the same composable function you defined in the beginning, and Compose framework is smart enough to recognize which composables have to change based on the provided state. And here are the main benefits advocated by the creators. Why should you adopt the Compose? And we will go through each of them and try to explain them in depth. By the way, how many of you have any experience with Android? Great. And did you maybe try Jetpack Compose so far? Okay, so it will be insightful for you. So the first benefit states that you will write less code to achieve the same result with the Jetpack Compose than using view-based system, using the XMLs. And here you can see some of the experiences from the companies which already incorporated Jetpack Compose. So they state that, for example, for styling some widgets, you need much less code. For writing the lists, because that's a common case for mobile phones. And I'll show you an example of that later in one of my projects. And lastly, animations are much easier because the API is much more concise. And here I wanted to show you, for example, how much code is needed to actually cover hold this screen with all the states it needs. So as you can see, we cover here the loading, success, and error state with these 20 lines. And of course, since it's a declarative, everything is rendered by the help of this UI state. Next benefit says that the Jetpack Compose is much more intuitive than XML. Why so? So at first, the answer lays in stateless UI components. You only have to describe your UI and to provide the state, and everything else will be done by the framework for you. And on the other side, there's like a theming where, for example, previously it was done across several XML files, and nowadays you can do it in a single Kotlin file, and I'll show you how. So here you can see everything is written in Kotlin. On the left side you can see some typography defined, on the right side some shapes. So yeah, now you can accommodate all the wishes from the designers about the rounded corner shapes much easier. And as well you can see here like a composable theme, where actually there is a custom logic where you can decide which theme to use. Like, do you want to use light theme or dark theme, or do you want to like use a dynamic color scheme? And everything is already in composable. The next benefit states that using Jetpack Compose will accelerate your development. And that's possible because it provides a lot of tools for you to work with. For example, as stated here, live previews and live edit are great features because while you are developing, you are able to see all the states, and you can actually, with the live edit, you can change the app right after saving your code changes. And yeah, here I wanted to show you some of the previews. So with the previews, you can actually define different attributes. So as you can see here, you can define device size, you can define locales, you can decide if you only want to render composable or the whole screen. And as you can see here, with these 3 different previews, I provided 3 different states, and thus I can see all the variations of my screen already in a preview, so I don't have to start my app for that. And the last benefit we'll talk about today is that Jetpack Compose is a powerful toolkit because it provides you direct access to Android APIs such as material theme, animations, dark theme support, and much more. And on the other side, it also enables you to use some supporting tools, for example, Relay tool, which can actually help you to connect your Figma and Android Studio. In Figma, designers can, I guess you're all using Figma if you are somehow connected with the front-end development. Designers are designing their screens there, and yeah, you have to code that, and as you probably know, there are a lot of misalignments between their ideas and tools possibilities. So this will hopefully help us to bridge that gap. This is still in alpha phase, so I hope it will be broadly used in the future. So yeah, since we mentioned all the good things, it's okay also to mention some things you should consider if you decide to incorporate Compose UI in your project. So as stated here, composable functions can execute in any order, and it's important for you to know that so that you can keep your app in a consistent state by making all the composables self-contained. Otherwise, yeah, something unexpected can happen. On the other side, also composable functions can execute in parallel, so again, make sure to have no side effects in your composables. And recomposition can skip as many composables as needed. So as we talked at the beginning, Compose framework will decide, based on a provided state, which composables should be recomposed, and the ones which should not be recomposed will be just skipped. So again, make sure to not have the side effects, otherwise you will end up in an inconsistent state. And the next point is that recomposition is optimistic and it can be cancelled. So for example, since I already told, there is like a good support for animation, so you can imagine that if some animation is recomposing, the frames are like constantly changing, so some recomposition can be skipped, and if you have side effects in your composable, even though the recomposition is skipped, the side effect will be triggered and you will again end up in inconsistent state. So make sure to avoid that as well. And it's connected with the last point as well, which says that recomposition can be triggered quite frequently. So make sure to avoid extensive operation in your composables. But I guess that's the same with any other UI framework. I mean, this is just to state that Compose cannot help you if you poorly designed your app. It will still be slow. Okay. Yeah, and now the red points, the drawbacks. Luckily, there are only a few which I could found so far. So the first one is that unfortunately still not all UI components are available with Compose. So yeah, you might end up in a state where, for example, there is some component, UI component for the view-based system, but it's not still available for the Compose, hopefully. There is one repository which comes to the rescue. It's called Accompanist repository. So these guys are already making wrappers for such components. So yeah, warm invite to check out that repository if you end up in such issue. And the second point is that actually the including of Jetpack Compose can affect your app size and build time performance. How so? So as you can imagine, Jetpack Compose dependency is not the lightest dependency you can include in your project. So once included, and you still don't have much composables in your app, your UI is still in XML files, it will increase your app size and slow your build performance. But after you migrate some screens, you will be able to remove a lot of XML files from your project. And as you can see on this diagram, after full migration, Compose-only projects are much smaller in app size, and they have smaller build times than view-only apps. So yeah, my advice here is just to be patient, and you will get in a good position after migration. So yeah, since we mentioned all the points, let's talk about the real stuff now. So how should you do it? So I would say here that the incremental migration and interoperability are the keywords. So since Compose is interoperable with the view-based system, you can actually start with your migration tomorrow, because the only thing you need to do is to include Compose dependency and start writing composables. As you can see here, so you can use composables in your views and vice versa. You can use views in Compose, so nothing stops you to start using Compose in your project. We will check these two approaches. So the first approach is to use Compose in your views. There are like two variations. If you're lucky enough to use composables directly from the activity and your whole layout is composable, then you can benefit from the setContent method in the activity and invoke your composable right there. Otherwise, you have to have the compose view, and you will call the setContent method on it. On the other side, if you decide to use views in your compose, that's like less probable, but still useful for the use cases I already mentioned for some components which are not yet available in compose, such as, for example, add view. Or, for example, you have your view already written in XML and you want to incorporate it in some screen you already wrote in composable, and you don't have the time to migrate that specific view as well. So you can wrap it around this Android view and instantiate in factory, and you're good to go. So yeah, that's mainly it about the theory. So we will dive now into some projects I prepared for this talk, and I learned from experts. Thank you, Nicholas, for this tip. Hopefully you can still hear me. Great. So yeah, I want to show you two projects. First one is the project I wrote several years ago already, and it's like some statistics for Premier League. It's quite old, so as you can imagine, it has its layout written in XML. So what I did, I migrated two screens to show you the actual difference in the code. And let's check. Okay, yeah, this just confused me. Yeah, firstly I can show you the actual app. So as you can see here, it has like a list of clubs. You can pick a club, then you will see the player. You can match the statistics of players. And there is a settings page where you can change the localization. Here you can choose between English and Serbian. So how it looked before, you can see, for example, here settings fragment. Here we used data binding. That was popular at the time when I was writing this project initially. And here, hopefully you can see, let me try to increase the code here. Here you can see the XML layout for this screen, and there is some data binding. And for this you had to use the binding on the fragment side. Here is how you show the dialog, and here is the actual data observer which binds the data with the view. On the other side, for example, standings fragment, that's the screen I showed you first. So this is the screen. As you can see, we have here a list. So previously, how the lists were created in Android, we were using recycler views, and each recycler view has its own adapter. So here I defined the adapter, and the adapter has its own diff callback, and as any other adapter, methods for creating item views and binding the data. And that was the initial state. So now I want to show you. Okay, I changed something unintentionally. Okay, go away. remove these. Whatever. How can I stash them? Thanks. Thank you. So, let me close this. The layout is the same, will stay the same, but the code underneath it is much more different. So, let me show you the settings screen first. So, as I mentioned, since we are not instantiating the compose from the activity, here we have to use compose view, and on it we are calling the set content method, in which we are declaring our composable. And here is how our composable looks. So here we have the state for showing a dialog, and besides that we have a whole UI written inside of this composable, and based on this, as I already said, based on this UI state, we are deciding if we want to show the dialog or not. And yeah, here are some callbacks provided, and at the end, previews. So as you can see here, for the preview, we can provide some attributes, as I mentioned, some so locale, and do we want to show the whole screen or not. And on the right side, you can see you can see the preview variations. So yeah, here you can see the settings screen preview, and besides that one, there is a language dialog preview with already chosen language. So if I change here language, English, hopefully, yeah, the preview will be rendered right away. So this is like this is the common case you will face, that you will have both XML files and compose files in your project. On the other side, like if you're lucky enough, you can start a new project, the greenfield project, with only composables. So I did that for learning purposes, and I'll show you that project now. So here is another project I want to talk about. So this is small project with some funny API about Chuck Norris jokes, and I use it besides learning the Jetpack Compose. I use it also to set up CI/CD. So yeah, if you're interested in that, make sure to check out the repository. And let me show you the code. So here, as you can see, everything is written in Compose. So let me zoom it and split it so we can see the preview. And this is the project I used to take screenshots for the presentation. So you can see here that again everything is based on a UI state, and we are providing the callbacks. So nothing is done directly from the composables. It only renders the state. And let's check on the bottom. There are 3 previews, and each preview has its own state, so it renders different state. And what's interesting here is that, for example, for the loading preview, you can see here, but it's static. So if you want to see the animation, that's also possible. You can run only preview. You don't have to run the whole app. And now you can see the animation as well. Yeah, as I mentioned, since this project was created in order for me to set up the CI/CD, as you can imagine, I needed some tests, so I wrote some. Okay, terminate this. Great. So I want to show you that as well. So how do you do it? It's much easier because all you have to do is to set the test tag to any composable you want. So yeah, we are avoiding this find by ID from the XMLs. And let me show you the tests. So these are basically UI tests. So yeah, watch and admire. So these are 3 UI tests, and if you ask me, they are quite fast. I mean, yeah, you can argue that the project is quite simple, but still, I doubt you to do the same with the XMLs and some framework for UI tests with XMLs. So I want to show you here how it's easy to write the UI tests for composables. So only thing you need is this compose test rule, and what do you do? So you set content on that rule. So I instantiated the composable I created and passed the UI state. So what I'm doing here, for example, so I'm passing different UI states, and once the state is passed and the screen is rendered, I'm checking the nodes. So that's why we needed these test tags. So test tags. So as you can see here, you just need this on node with tag method, and you have your composable, and then you can assert what you want. For example, if it exists and if it's displayed. And yeah, I think that's all regarding the code. So we can get back to the presentation. Okay. Come on. Okay, I'll have to do it manually. Go. Yeah. So yeah, once again, the key takeaways I would like you to take from this today. So first of all, if you plan to do it incrementally. Well, I mean, because it's possible. Otherwise, you would have to break the walls. But thanks to interoperability, as I said, you can have both in your projects. And as you saw from that demo, on the other side, start from small independent components, because you will be learning along the path. Trust me, my first composables didn't look this neat at the beginning, but yeah, you will get there. Yeah, also great recommendation is to write all new features in Compose if possible. I mean, I understand that since it's new, it might be a bit inconvenient, but in the long run you will benefit. Also, you can replace your existing features one screen at a time to avoid additional confusion. And lastly, the sooner you start, the easier your maintenance will be in the long run. So yeah, I would advise to start with the Compose as soon as possible. And these are the resources I used. So the 2 projects. For the projects I showed, there is a live demo session where I actually coded this. So here I wanted to show you more. That's why I opted out from the live coding and went through 2 projects. And besides that, some cool blogs I used as resources. And yeah, thank you for listening, and now it's time for your questions. Yeah.
As a user of As a user of Node and other programming platforms, the first trouble I run into is the dependency that usually requires you to maintain continuously the files, or to check if the dependency can run into a compatibility issue. Is this happened to you, and has this happened often, and how do you solve it with Jetpack?
Yeah, thanks for the question. Of course, it happens that we are having like dependency clashes from time to time, and it's awful experience always. But yeah, thankfully, Google is now releasing their dependencies in bundles, like bill of material. Like those are like packages with several dependencies packed in one bundle. So yeah, thanks to that, there are like less and less conflicts. But yeah, once that happens, you have to find the conflicting ones. I mean, for the Android, Gradle comes handy for that. So yeah, firstly you have to like find the conflicting ones, exclude probably the older one, and resolve the conflicts in that way. No, I mean, the good thing is that if you are using latest and greatest, it doesn't happen too often. But the thing is, of course, we all have some old dependencies, probably some proprietary libraries from some external service providers in our projects. And usually it happens with these kind of dependencies. And it depends. It's not always like a coding issue. Sometimes it's like issue of communication. Then you have to like call or contact those service providers and tell them to either update their dependencies or to exclude them, or yeah, to resolve it in some other way. But as I said, it's always awful experience. You're welcome.
Thank you. Really good presentation. Are those UI components taking into account accessibility?
Yeah, of course. Actually, for some components, such as, for example, images, nowadays content description is required attribute. So yeah, you are basically forced to take into account accessibility, which is, I think, great. And yeah, I mean, it's used for voiceover and much more. You're welcome. Any other questions? If not, again, grazie.